Hey folks, welcome to this episode on covalent nomenclature and formulae. So, to figure out how to name something, we first have to figure out what we're naming. It's either going to be ionic or covalent. So the ionic or covalent. Now, if it's made up of a cation and an anion, usually that's a metal and a non-metal. Then we have ionic. But what we're going to be focusing on today is things that are made up of non-metals only, the molecular. So in this lesson, we're going to be focusing on this branch here. So remember what covalent bonding is? It's the sharing of electrons to achieve a full outer shell. In this case, we have methane on the bottom here. Hydrogen contributes one of these electrons from its unpaired electron, and carbon contributes the other unpaired electron. So together, they're going to share to create that full outer shell. And again, hydrogen only needs 2, carbon needs 8. And so we get this this molecular formula or chemical formula, in this case CH4. So this is what we're going to be looking at today. Remember that diatomics are this more simple covalent molecules. It's really when we have one atom bonded to itself. Now, diatomic, these elements go under diatomic or become diatomic molecules. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And then we have PS, and that's phosphorus and sulfur, which become polyatomic. P goes into P4, and S is into S8. So we'll take a look at that in a second. But when we're naming these, we simply just name them as sulfur, or if we're talking about a diatomic molecule, and for example, Cl becomes Cl2, this is just going to be called chlorine. So we just use their simple names even when they're found in this diatomic molecule. So this is how they exist when they're not in a compound. So here are some diagrams here of what we're seeing in the polyatomic ions. We have our diatomic molecules from hydrogen all the way to iodine. Okay, and again, you can see that most of them are single bonds, with the exception of nitrogen, which is a triple bond, and oxygen, which is a double bond. Here we have our polyatomic ions. This is our phosphorus, so it forms this kind of triangular shape or pyramid shape. And then we have this eight atom shape, this polyatomic structure, and this is what sulfur usually goes when it's not existing in a compound. So you can see that most of these nonmetals exist in some form of diatom or polyatomic molecule. Now, in this case, when oxygen is produced in this reaction, if you remember what this reaction is, okay, that's cellular respiration. When we have O2 gas, it's just simply named as oxygen. Okay, so there's no dioxide or anything like that. It's just oxygen. So when it comes to naming, we have to follow these steps to name these binary molecules. Binary just means that it's made up of 2 elements. So it could be like HBr or CO2. 2 types of elements. It doesn't matter how many there are of each element, but we just have 2 elements, CO, HBr. The first thing we need to do is name the first element as is. So in this case, the first element would be this one. And then the second element we just change to ide. Now notice how in CO2 there's only 1 C and there's 2 oxygens. So to indicate how many atoms there are, we're going to be using these prefixes. The only thing that you have to remember is that we never use the prefix mono on the first element. And the prefixes that we're talking about are these Greek prefixes over here, mono, di, tri, etc., etc. There's only one note to take into account. Whenever we have something that's a simple molecule that's made up of hydrogen and another atom, HF, HCl, HBr, HI, HCN, they're often simplified. We actually forego the mono altogether. So instead of saying hydrogen monofluoride, for example, for this one, we just say hydrogen fluoride. We just say hydrogen fluoride. Oh, fluoride. So we forego the mono in front of the F. So again, if we had HCl, then it would just be hydrogen chloride. We still change the ending to ide at the end, but we forget the mono in the front here. Okay, so this is only when we have hydrogen bonding to some other atom. So here's an example. We have 2 examples here. So we have CO and we have N2O. So CO, we name the first atom as is, so that is going to be carbon. And the last one is oxygen, but we change the ending to ide, so it's going to be oxide. Okay, now there's only 1 of each. There's 1 carbon and 1 oxygen, okay, because the subscripts there's no subscript, so the subscript must be 1. Now we don't write mono on the first one, but we do write mono on the second one, so we say monoxide. We don't write monoxide because then there's 2 vowels beside one another. Okay, so the second one, N2O. So again, we write the first one as is, nitrogen. And again, the second one, we change the ending to ide, so it's oxygen. Change the ending to ide, so it's oxide. Okay, now we see that we have 2 nitrogens, and 1 oxygen. Again, because there's no subscript, that subscript is 1. So the 2 from the nitrogen is going to be di, so we say dinitrogen, and there's only 1 oxygen, so we say monoxide. So go ahead and pause this video and try to come up with the names of these following compounds. When you're done, unpause and the answers will be there. Alright, welcome back. Here we have the answers to the names. So we have diphosphorus pentoxide, 2 phosphorus, 5 oxygens. Dichlorine heptoxide, again, we want to reduce the amount of vowels. Cl2, well, that's a diatomic molecule, so it's simply going to be called chlorine. And HBr, well, it starts with H and it's bonded to something else. We simplify it, we just say hydrogen bromide instead of hydrogen monobromide. Now, how do we go from names to formulas? Oh, it's actually very, very simple, because the prefixes tell us how many atoms there are. So all we have to do is convert the element names into the symbols, and then convert the prefix into subscripts. Now remember that if you have the word mono, then it's going to be 1, and we don't write ones. That's the simplification. And if in the first name there's no prefix, well, also remember that that prefix is going to be mono. There's only going to be 1 of those. So let's take a look at these. Here's some examples. So dinitrogen tetroxide. So the first thing we want to do is we want to change the names into symbols. So the symbol for nitrogen is N, and the symbol for oxide, well, that's oxygen, is O. So here in the front we say we have dinitrogen tetroxide. So di is 2, so that converts into a subscript of 2. And tetroxide, this is tetra, that means 4. So we're going to have N2O4. We don't simplify. Okay, we don't simplify this any further. This is our molecular formula. It shows the exact number of number of atoms of each element in the compound. So go ahead, try the last 2, iodine heptafluoride and oxygen difluoride. Pause the video and come back. We'll have the answers for you. Welcome back. So in this case, iodine heptafluoride, that's iodine. Because there's no prefix on here, that means it's going to be for sure mono. So that means our subscript is going to be 1. We don't write the 1, so it's just IF. And again, we have 7 fluorine, so IF7. Oxygen difluoride, similar situation. We have oxygen, which is O, fluorine, which is F. We know that there are 2 fluorines because it's difluoride, but because there is no prefix here, we know that that's going to be 1, so we just write OF2. Now, the only case that we're looking at where we're going to have some maybe different atoms, more than 2 atoms, are polyatomic ions. And these are charged species that are composed of 2 or more nonmetal atoms, and they're covalently bonded together, and they act as a singular unit. So, for example, when we have something like NO3-, this will always act as this NO3- unit. So if we're adding it to an ionic equation, it's always going to stay as NO3 with a charge of 1-. So these are the ones that you're going to have to know. You're going to have to commit them to memory. Hydroxide, nitrate, chlorate, carbonate, sulfate, phosphate, ammonium, hydrogen carbonate, acetate, and dichromate. We're going to be working with these a little bit later when we're going to talk about oxyacids. So make sure that you commit them to memory before then, and also before our ionic lesson, as we're going to be using them quite extensively there. So these are called our base polyatomic ions. We can change the number of oxygens on this, and we'll see how we do that a little bit later. So that's it, guys. Thanks very much. See you next time.